All right, welcome again to another one of Mr. Martin's math videos. This is a video specifically for British Columbia. Pre-Calculus 12. We are looking at Chapter 8 on logarithms and Section 4 of Chapter 8, logarithmic and exponential equations. So in this section, we're going to be using the relationships between logarithms and exponents to solve some somewhat intimidating equations, at least to the person who doesn't know how to use logarithms. But that's certainly not you, right? Before we get into the algebra, I just want to point out an important fact that will help us in solving these equations. Consider the following equation. Here we have log CA equals log base CB. And so what can you say about the relationship between A and B, given that they are both inside a logarithmic expression with the same base? So because they have both logarithmic, both in a logarithmic expression, and because they have the same base, and the equation is equal to each other, the assumption that we can make then is that A must be equal to B. Okay, and I'm going to make my pen a little bit bigger. All right. A is equal to B. Okay, that's an important assumption that we're making here, and it's an assumption that's going to help us out in these equations. Okay, so this fact is going to be very useful as we are solving various logarithmic exponential equations. So let's take a look here. For example, solve the following equation. Log base 6, 2x minus 1 is equal to log base 6, 11. All right. Well, here, notice again that we have log base 6. So we have both logarithms with the same base. Therefore, A, which is 2x minus 1, and B, which is 11, must be equal to each other, right? So because they have both log with the same base, I can say that 2x minus 1 is equal to 11, and then go on solving from there. However, before I finish this, I need to think about the restrictions, okay? And the restrictions is that there's no, remember, if I were to change this to an exponent, okay, it would look like this, right? 6 to the, just 1/2 of this, okay? 6 to the y, let's say, is equal to 2x minus 1, okay? Now here, if I had a value for x that made this side of the equal sign either 0 or a negative number, there was no possible y value that could give me a 0 or a negative number when we're in logarithmic or exponential form, right? That's why an exponential graph, if you were to sketch the graph, it looks like this. Goes and then it swings up. There is no value for, in this situation, it's for y actually, on this graph here, okay, that you can get a negative output or an output of -1, okay? The asymptote is that x-axis, okay? So our restriction is based on that, okay? That let's do it on the side there. So our restriction then is based on the fact that 2x plus 1 must be greater than 0, okay? Not equal to 0, greater than 0, all right? And so if you just do the quick algebra, that means that x must be greater than, oh, sorry, it's minus, not plus 1, -1. That's why I was -1. So x must be greater than 1/2. Okay, if you do the algebra, that's where you end up. So that's my restriction. X must be greater than 1/2. All right. So now that we're ready for that, all that's left is some simple algebra here. Plus 1, which gives me 2x is equal to 12. X is equal to 6. We're all done here. Okay. Now, and we always have to test is here my restriction says that x must be greater than 1/2. And here my answer is x is equal to 6. Is that a possible answer? Is 6 greater than 1/2? Of course it is, so we can move on. We've done it correctly. Okay? All right, same situation here. I have a couple restrictions that I'm going to have to come up with, right? Because I know that 8x plus 4 must be greater than 0, and x plus 1 must be greater than 0, okay? So that's going to give me x must be greater than negative 1, and x must be greater than negative 1 over 2. Okay, if you simplify both of those, that's what you'll get. Now, here, you have two restrictions, but really you only have one restriction, right? Your restriction that you use is the most restrictive restriction. It's the restriction that is the most exclusive. I like to use that expression, okay? So there are more numbers, even though it's relative infinities, but there are more numbers, there are less numbers possible with this restriction, right, than with this restriction. Because for the above restriction, even if I have like oh, actually, no, wait, no, it's the opposite, actually, in this situation. X must be greater, so there are less numbers possible in this restriction than in this restriction, okay? So my real restriction is x must be greater than negative 1/2, okay? Because x could be negative 3/4, okay? And that would be greater than negative 1, but it would still be smaller than negative 1/2, okay? So you take your most restrictive restriction, and that's the one, okay? The restriction that if it follows that restriction, it automatically respects both restrictions, okay? That's the one that you put into your restriction. All right, now let's get to work here. Log, they both have the same base, and it's a base of 10, okay? So here, and I'm going to move, there's a couple ways here. Here I have this 1 here, right? Now, in questions like this, we have to be able to see what is the log behind that 1 of base 10. If I have log with a base of 10, okay, which all of these have, right? 10, and then the next one as well, plus log, it's an invisible 10, but the 10 is there. In order to make this equal to 1, what must be the value after the base 10 in order to equal 1? Okay, well, from the last set of notes, we know that that would be log base 10. 10 is equal to 1, right? Because 10 to the what is equal to 10. Well, it's 10 to the 1. So that's what, that proves there. Okay, so now everything's in logs, okay? And then we can combine, based on the product law of logarithms, we can combine these two, okay, and we can get rid of the logs, and it gives me this, okay? Gives me 8x plus 4 is equal to 10 times x plus 1. Okay, maybe I shouldn't have skipped a step here. Let me go back. I'm going to keep this one the same. Log 8x plus 4 is equal to, because they have matching bases, all right, I can put this as log 10 times x plus 1, okay? And that's when I get rid of the logs, because they have matching logs with matching bases, which leaves me with 8x plus 4 is equal to, and now I can distribute that 10 into my bracket. 10, I'll do that next step. X plus 1. I don't want to lose anyone here as we do this. So now I would distribute the 10 and then solve for x, right? So 8x plus 1, 4 is equal to 10x plus 10 minus 8x minus 8x minus 10 gives me negative 6 is equal to 2x. X is equal to negative 3. Okay, that's my solution. Now, is that a proper solution? Does that solution fit in my within my restriction? Is negative 3 greater than negative 1/2? The answer is no, right? So this is actually an extraneous root, or an extraneous solution, I should say. It's an extraneous solution. All right, so the only answer we get there actually ends up being an extraneous answer. Okay, and that's possible. That's why we have to accurately determine our restrictions and also check our final answers with those restrictions. All right, one more question together, and then I'll try one on your own here. Again, here we're looking at a restriction, right? Here, because it's squared, the number can be negative because it's squared. Negative times negative gives you a positive. It just can't equal 0. So in this situation, x plus 3 cannot equal 0. X cannot equal negative 3. So that's my restriction in this particular situation. All right. Let's go from there. Log base 2 x plus 3 squared is equal to, now again, you're looking to change this 4 to a log that has a base 2. Okay? So here, log with a base of 2 would be, and you can always return it to exponential here, what would equal 4 in this situation here, right? So, so 2 to the 4 is equal to what? Is equal to 16, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be log 2 to the 16 that would equal, that would equal 4. Okay? So that's how you determine that. So you have to be able to kind of move from the numbers like 4 here to a log with the appropriate base. Okay, and that'll become more familiar as you go. Then from here, because we have those matching logs with the matching base, we end up with this equation here, which is just x plus 3 squared is equal to 16. And then we get x squared plus 6x plus 9 is equal to 16. X squared plus 6x plus 20, minus 16 on both sides, minus 7 is equal to 0. And then we can factor this back out to x plus 7 and x minus 1 equals 0. So here it means that x is equal to negative 7 and x is equal to 1, okay? Now, for here, are either of these extraneous? Are either of these, x cannot equal negative 3. It can be negative, but it can't be equal to negative 3. So both of these are good solutions. Okay? All right, go ahead and pause the video and give this one a shot on your own. See how you do, and then unpause the video. We'll go from there. Okay? All right, hopefully that went well for you. Here the restriction's pretty straightforward. X must be greater than 0, okay? It's not a part of any kind of complex or binomial, trinomial, or anything like that. It's not in a bracket. It's just X. That must be greater than 0. And then let's go from there, all right? Now we can combine these logs, log 7x plus log 4x, into log 7 4 times x is equal to log 7 12. And again, we have those matching logs. And I get 4x is equal to 12. X is equal to 3. Okay? And 3 is greater than 0. That's my final answer. All right, hopefully that one went well for you. Let's try some that are a little bit harder on the next page. Okay, I want you guys to try these as well. Pause the video. All right, give these a shot, and then come back, and we'll try to solve these together. All right, how did that go? Hopefully you had some success here. First, we got to figure out our restrictions here. For our restriction kind of work, here it says that x minus 6 must be greater than 0. And so x must be greater than 6, and then x minus 4 must be greater than 0. X must be greater than 4. So here, if you have a limitation, let's say a ride, a roller coaster, and you must be 6 years of age, or you have to be older than 6 years old, right? That's what this is saying. Okay? Well, that automatically excludes all 4-year-olds, right? And so that restriction is more exclusive than if you were to say all participants must be older than 4. Well, you could be 5 and go on the roller coaster, and so the x is greater than 4 is less exclusive than x is greater than 6, and so this would be my restriction, the most exclusive one. Okay, the restrictive restriction is the one that you want to kind of go off of, okay? Because if it satisfies the most restrictive restriction, then it satisfies both restrictions automatically. All right, let's take a look. So here I want to change all my logs. Okay, so log 2, x minus 6. All right, here I need to change that 3 to something that has a log of 2, right? And so again, change this to exponential form. 2 to the 3 is equal to 8. So log 2 to the 8 would equal 3, right? And we can always double check that work. Math, log base 2, 8, press enter, it equals 3. Okay, so you never have to get these wrong. You can always check your work. Then minus log base 2 x minus 4. Okay, let me put a line there to separate the restrictive work. Okay, I can't just cancel out the logs here and start minusing 8 minus x minus 4 because that doesn't work. First, I need to use the quotient law of logarithms, which we learned last class as well, which says that log base 2 is 8 divided by x minus 4. Okay, then at this point, once you have only one log symbol on both sides, that's when you can cancel it out and say that x minus 6 is equal to 8 over x minus 4. Okay, and then from here, you can x minus 4 on both sides. Okay, then it's going to get quadratic here. Once you FOIL, which is x squared minus 10x plus 24 is equal to 8. X squared minus 10x minus 8, so that's plus 16, is equal to 0. All right, and you can factor this out as x minus 8 and x minus 2 is equal to 0. X is equal to 8, x is equal to 2. Okay, so those are your two solutions. Is there one of these solutions that does not, one or two of these solutions, do these solutions fit our restriction of x must be greater than 6? X is equal to 8 is greater than 6, so that one's good. But x is equal to 2 is not greater than 6, and so this is extraneous. Okay? All right, hopefully that makes more sense now that we're looking at these types of problems. Let's try another example problem here. Okay, again, I need to figure out a restriction. So x squared minus 8x must be greater than 0. All right. And so in this scenario here, you'd have, for restrictions, you've had x bracket x minus 8 must be greater than 0. So I have x must be greater than 0, and x minus 8 must be greater than 0, so x must be greater than 8. So again, which is the most restrictive restriction here? It's obviously x must be greater than 8. So x must be greater than 8 is my restriction. Okay, that's my restriction work there. Now let's get to the actual solving here. I have log 3 bracket x squared minus 8x, close, exponent 5, okay, is equal to, all right, and then here I need something that's log to the 3 that's going to be equal to 10. So again, always go back to exponent form If I have log base 3 to the, to a is equal to 10, then 3 to the 10 is equal to a. And I want to know what a is, because that's what I'm going to put here. Okay? That's what I'm going to put here. So I enter 3 exponent 10, and that gives me my a value, which is significant in this case, 59049. Okay, so now I've put that there. Now I have matching logs with matching base on either side. Those cancel out. I get x squared minus 8x exponent 5 still is equal to 59,049. Okay, so here you think, oh, there's going to be a lot of foiling. Just 5 root both sides. Okay, and then you're going to get x squared minus 8x is equal to 5 math x second function answer, which puts that 59,000 in there, and I get 9. Wow, that's a nice, neat answer. So I get this, and then of course we're back into quadratics here. We're just factoring minus 9 is equal to 0, x minus 9 and x plus 1 is equal to 0. X is equal to 9, x is equal to negative 1, and right away I can tell that this is extraneous. Okay, and only this is the correct answer. Just like, okay? Because only 9 is greater than 8, negative 1 is definitely not greater than 8. All right? All right, so rewatch those slowly if you need to, kind of see the steps that we go through to solve these kinds of problems. All right, let's do some of these questions now. Okay. So these get a little tricky as we go, right? So we're going to do one, and then you're going to answer one. Some of these first ones are pretty easy, but they will get a little bit tougher as they go. All right, so these are equations I told you about last chapter that you don't solve without a knowledge of logarithms. Now that you've been enlightened, let's see how you can tackle these problems. All right, and we're just going to round our problems for the first decimal. This first problem is very easy. This is what logarithms are meant to answer, right? Because here I know that I can change this to log base 4, then 605 is equal to x, right? And then all that's left is putting this into my calculator and getting my answer, right? So log base 4, and then 605, 05. And I get my answer of x is equal to 4.62. Right? That's pretty straightforward. That's what logarithms were meant to do, well, at least in the initial phase when we learn them for exponential functions. They're meant to help solve that exponent, that unknown exponent. Okay, so just for this, go ahead and pause the video and try D there over to the right. All right, hopefully that went well for you. Here, I'm going to change this to log 2 to the 2500 is equal to x. I could also do that if you're using a different calculator. You can use like the TI-83. You can use log 2 2500 over log 2. That would work as well. Either way, x is going to be equal to log 2500 divided by log 2. I get 11.29 as my answer. If you don't believe me about both methods working, I'll just do both here just so that you guys can be sure here. Both ways you get the same answer. Okay? All right, good. Pretty straightforward. This next one here, now we have kind of a bit of a term, with a coefficient and an x, or you can even get a binomial in that exponent. That can be a little bit pesky to deal with, but we're just going to use the A method to solve for this by substituting 2x by a, and then we'll sort it out afterwards. So, but first I need to isolate this exponent. So I'm going to divide both sides by 8, and that's going to leave me with 3 to the 2x is equal to 568 divided by 8 is equal to 71. Okay, and I'm going to use the A method. The A method simply says that 2x is equal to A, so I'm going to substitute A in the place of 2x and just solve for A and then substitute it back to 2x. Okay, so this is going to be log 371 is equal to A. Math log base 371, that's equal to A, so which is equal to 3.88. And so in this situation, 2x is equal to 3.88 divided by 2, x is equal to 1.94. 1.94. That's your final answer there. Okay, using the A method, that's a good method for some of these problems. Okay, go ahead and pause the video and try E. Okay. All right, hopefully that went well for you. Again, we're just going to use the A method. First, I'm going to define the A. Always helpful to define the A to make sure that you don't lose track of anything. And it's 5, substitute A in the place of my x minus 3 is equal to 1700. And then log 5 to the 1700 is equal to A. Math log base 5 to the 1700. So this gives me A is equal to 4.62. And so x minus 3 now, because I know that A is equal to 4.62, I substitute the value of A back into this equation, and then I just solve for x now. So plus 3, x is equal to 7.62. So that's pretty straightforward. All right, now these problems at the bottom here, and I'll try to post some assignments that kind of give you more reps in these kinds of questions, because these can be a little bit trickier, these problems here. Because the A method is not really sufficient for these kinds of problems here. All right, so we're going to be using a different approach to these problems. Okay, so the first thing we're going to do is we're going to change these into logs. Okay, because they are equal to each other, if I put log in front of both of them, they'll still be equal to each other, right? So if I say log 4 to the 2x minus 1 is equal to log 3 to the x plus 2. Okay, so that's true. Okay, now because these are exponents, okay, I can move them to the front based on the power law of logarithms that we learned last class. So that's going to give me 2x minus 1 bracket is equal to log 4. And then here it's x plus 2 is equal to log 3. All right. Now what we're going to do is we're actually going to distribute log 4 and log 3 into the exponent we just moved to the front here. So we're going to distribute this log into the bracket here. So that's going to give me 2x log 4 minus log 4, because negative 1 times log 4 is negative log 4. And this is going to give me x log 3 plus 2 log 3. All right. So far, so good. Okay. Now, what I want to do here is I want to bring all the variables to one side, the log terms with variable x in them to one side, and log terms without variable x to the other side. So I'm going to add log 4 to both sides here. So plus log 4, and I'm going to subtract x log 3 to both sides. Now these aren't like terms, so I can't add them, right? But I will kind of just line them up, and it cancels out there. So I'm going to get 2x log 4 minus x log 3 is equal to log 4 plus 2 log 3. Okay, now I want to do some factoring here. Okay, I'm going to factor out x, or any like term, anything I can factor, greatest common factor on either side, and I'm going to factor out if possible. All right, so in this situation, I can factor out x. So I can factor x out of both terms. All right, and that's going to leave me with 2 log 4 minus log 3 is equal to still log 4 plus 2 log 3. And now notice here that I can now divide both sides. I have x isolated here. Okay, I've been able to isolate the x variable just in that red x there on the far left. That means if I divide both sides by this bracket of 2 log 4 minus log 3 on both sides, 2 log 4 minus log 3, I'm going to get an answer that is equal to x, right? So now all I have to do is plug this into my calculator and I get my answer. So let's do that. I have bracket log 4 plus 2 log, just watch your brackets here. You need a bracket in the numerator and denominator, and the entry bracket for the log, divided by bracket 2 log 4 minus log 3 bracket, and I get my answer of 2.14. Okay, how did that go? Were you guys able to follow that? I want you guys to give it a shot. Okay, there's a problem there, F, right next to us. Okay, I want you guys to pause the video, give it a shot, then unpause, and we'll go over it together, and you'll have 2 of these questions under your belt by that point. Okay, so let's go from there. All right, let's give this a whirl. So here I just, put in the log 6, 3x plus 1 is equal to log 8x plus 3. All right, that's going to give me 3x plus 1. Log 6 is equal to x plus 3 log 8. Okay, then distributing logs everywhere here, and I'm going to get 3x log 6 plus log 6 is equal to x log 8 plus 3 log 8. Want to bring all my x variables to one side, and logarithm terms with x variables to one side, and all the log terms without x variables to the other side. So minus x log 8 minus log 6 minus log 6. That's going to cancel out this one. And this one is going to leave me with 3x log 6 minus x log 8 is equal to 3 log 8 minus log 6. All right, now I'm going to factor out the x's from the left side. Okay, greatest common factor here for this term, I can factor out x, and by doing so, I isolate x. And that leaves me with 3 log 6 minus log 8 is equal to still 3 log 8 minus log 6. And because I can isolate my x here, if I divide both sides by the 3 log 6 minus log 8, Okay, mind your brackets. That's going to cancel out, isolating my x variable. And then, again, I just plug in this into my calculator, and I'll get my answer. Okay, so once again, denominator 3 log 8 close bracket minus log 6 bracket bracket divided by bracket for my denominator 3 log 6 close bracket minus log 8 close bracket and close bracket my denominator. I press enter, I get my answer of 1.35. Okay, so those are significant questions. I wish I had more practice questions like this on in the notes. However, do look through the class notebook. I'm going to add some additional kind of practice questions like this, including a maze activity that you can do to kind of as a practice for the section. I'm also going to include a practice test for Chapter 8 as well to help you prepare for our test coming up on Friday. Yeah, Friday. All right. So otherwise, maybe we'll do I think we'll do the maze activity on Thursday. Those of you guys who are coming into the class. Anyways, assignment is there at the bottom, your homework, 8.4. This is the last section of the school year. Last homework assignment of the school year. Woot woot. Well done, everyone. And we'll see you next time. Hope these videos have been helpful.